So I'd like to introduce our next speaker now. She's been a friend of us here at RAL for many years, first in roles at Surrey Satellites Limited, working her way up to director, and then at KIPSI, the space systems expert. And then roughly a year ago, I guess, 8 months ago. So Anita took a new role as the head of MDA in the UK. And she's going to talk now to us about the innovation that they're carrying out in their projects here in the UK. Anita Bernie.
I brought my cup up with me because it's quite chilly. I could suggest we do some star jumps to kind of wake up after lunch.
Absolutely.
Maybe we'll wait till the duties later. So, as Paul said, thanks for the introduction. I've been the managing director of MDA since March this year, and having the most incredible time. It's a real pinch me moment to be the leader of such a fantastic space company. We're doing so many amazing things that, you know, it's going to be easy to talk for 20 minutes, probably longer if I had. So you'll have to kind of drag me off the stage. So I'm going to talk about the things that MDA is doing to innovate and stimulate to empower the future Earth and space economy. And I say Earth and space because there's a lot of activity that we work on, that we deliver for our customers, that's supporting the space economy on Earth across a whole range of different verticals and industries, and I'll talk about those, but also what's going on in space. We heard this morning about some of the exciting work that's being done in space exploration, and we are very much part of that ecosystem at MDA, both in Canada and here in the UK. Am I pressing the right button? So a quick overview of MDA. We have a 50+ year history of innovating in space. We're Canadian headquartered, but have a very global outlook. We have a presence here in the UK, also have a presence in the US. We've got over 2,500 people. In the past few years, we've been growing the team by hundreds upon hundreds every quarter, and doing that in a really innovative, agile way. My CEO, Mike Greenley, likes to call us a 2,500 person startup, because we're trying to make sure that we stay agile, that we're making sure that we're configuring ourselves to support the needs of our customers, many of whom are traditional space, but trying to do things with a new space flavour as well. We've got 3 business areas, and I'll talk about those in more detail as I go through the talk: robotics and space operations, geointelligence, and satellite systems. We've got this reputation that's been established over the past 50 years or so of being a trusted partner and collaborator with teams across the entire space ecosystem. That's across government, across institutional and commercial customers as well. So what are we known for? I mean, lots of iconic missions and systems. We develop advanced technologies that enable mission first, and we've been involved in so many of those over the past few decades. Everything from space robotics on the International Space Station and supporting some of the docking manoeuvres and activities that happen on station, through to flying our iconic radar satellites that hoover up vast quantities of information about the Earth's surface. And I'll talk a little bit more about CHORUS, which is our next generation, 4th generation SAR satellite, future on in this talk as well. So in terms of what we're doing here in the UK, we're based here on the Harwell campus. We have new purpose-built facilities that we moved into in the summer. I've got a nice but also difficult challenge at the moment, in that we've already grown out the space, and we're a victim of our own success, and that we've doubled and doubled again over the past couple of years. And my goal is to double our organisation again in the next 12 to 18 months, based off the contracts that we're currently winning and hoping to secure in the future. And that's across all 3 business areas. And our goal for the UK is to create a centre of excellence for cost-effective, commercial, new space sensors, robotics and communications payloads, as well as commercialising the work and the IP that we're generating in Canada, bringing the best of that, repeating that pattern, and bringing that into UK and European industry. So a few slides on some of our flagship programs. We heard this morning about exquisite science missions. Here in the UK, we're involved in Proba 3. we are developing the very precise metrology, laser-based satellite systems that are going to help to maintain 2 satellites in very precise configuration as they perform their solar science experiment that's going to be launching in next year. We have significant robotics experience with an expertise within MDA, and we're bringing that capability to the UK. We recently were part of a press release that was announced by the UK Space Agency because we are part of 2 teams that have been down-selected by the UK Space Agency to develop active debris removal missions, tying in very much with the theme of space sustainability. And of course, an iconic picture. If anyone's got a picture of an astronaut, something to do with the International Space Station, it has to go on a slide. This is a picture of an astronaut. It's cropped, but he was installing the Kolka communications terminal on the European module, and that was all manufactured out of the UK. I really love Gemma's new unit of measurement, which was crunchy nut cornflakes. So here in the UK, we are developing and will soon be flying a range of different sensors, different missions for the next wave of space innovations, for anything from lunar landing, which will be happening Q1, I believe, with Intuitive Machines, all the way through to supporting rendezvous and docking operations as well. And I love the cornflake packet analogy, because what we're trying to do with these systems is to make sure that they are as low swap as possible. It takes so much fuel, it takes so much energy, it takes so much accommodation to get anything to lunar orbit, that we're trying to make these as accessible and affordable and as performant as possible to support the emerging wave of commercial missions that are going to the moon. And we are a key supplier into many of those NASA CLIPS missions. So going through the 3 key business areas and keying in with what Paul was saying this morning, what are we doing to support humanity? What are we doing that's helping to support Earth's problems from space? Our 3 business areas are really helping to drive that development forward. So in terms of the challenges that we're helping to support, in terms of geointelligence, it's the need to address the growing demand for Earth intelligence and analytics. We talked about the climate emergency. A lot of work needs to be done around climate change monitoring. How can we make sure that we have enough food? How can we make sure that we're supporting the agricultural industry to make sure that food security and scarcity of food is being mitigated through having that knowledge from space? Illegal fishing detection is another one. The oceans are a very scarce resource, and it's really important that we maintain and monitor that scarce resource as responsibly as possible. I talked about RadarSat-2. That is our 3rd generation SAR satellite, C-band SAR. We have invested, or in the process of investing, $400 million into our 4th generation C-band SAR satellite, which is actually a new next generation C-band SAR with an X-band follower. So we can have a look over vast regions of what's going on on the Earth's surface, and then queue a higher resolution X-band SAR satellite that will go down and get a better look at the areas of interest. So a picture paints 1,000 words. I've got a series of videos as we go through my talk, and the first one I'm going to show you is some of the benefits that RadarSat-2 is providing. It's presented from a Canadian perspective, but the applications, the missions, the benefits it provides are being rolled out internationally as well. So here's the first one. Silence. What am I not doing right? Which do I need to press? Yeah, I'm clicking. Oh, mouse always works.
30. In December 2007, Canada's Earth observation satellite, RadarSat-2, was launched into space. Capable of scanning the Earth at all times, day or night, through any weather conditions, the satellite typically acquires more than 30,000 images a year. These images are used by research centers, private industries, and government departments and agencies across the country and around the world. The information they provide is used for a vast array of applications, from helping monitor fishing activities on our coasts to increasing our agriculture's profitability and sustainability. RadarSat-2 technology can be used to monitor landslide risks along strategic transportation and energy corridors, giving our country the means to better protect critical infrastructures. Because it delivers data in near real time, its images are also used to help coordinate rescue teams on the ground following natural disasters, making RadarSat-2 an essential tool where lives, communities, and the environment are at stake. RadarSat-2 collects critical information on remote or inaccessible areas, helping ships navigate safely through Canadian waters and enabling northern communities to plan safer routes for fishing and hunting expeditions. Space technologies developed for satellites bring new solutions to Earth challenges. The Canadian Space Agency is committed to fostering innovation for the benefit of all Canadians. Canadian Space Agency, thinking outside of the globe.
I need the mouse again, do I? See if I can forward this again. Why can I not figure this out? What am I doing wrong? Perfect, thank you. Our second business area is satellite systems, and really the challenge there is the need for us to be able to connect everything with everything, connecting people with one another, connecting our systems, our enterprises, and our communities. We are a global community, and everything is increasingly being connected to everything else. So we provide broadband internet capability, everything from connecting vehicles, Internet of Things, of course, mobile communications and defence applications. And that capability spans across all orbits, from LEO, MEO, GEO, and for exploration missions as well. And the reason that we're able to deliver a lot of this competitively and be so successful in the market is because we have advanced manufacturing capabilities. And I'm going to show you a video of our Montreal facility and the advanced capabilities that we have there that are providing the right price performance point for a range of customers around the world. Right, here's where I need the mouse, right? intelligent satellite systems, that's very much around what I call space for space, space for Earth. Although within our geointelligence business, we also provide space-based and ground-based space domain awareness. But when it comes to robotics, which is the last topic, it's very much space for space. I can figure out how to hit escape. Have I broken this now? Oh gosh, what have I done? All right, here we go. Great. So the challenge that we're addressing here is around creating those capabilities that are going to support the emerging and the future in space economy. There's a rapid growth of what's going on in orbit right now, where we're seeing the emergence of commercial crewed platforms alongside the ISS. Space tourism is now a thing. We've seen, as was mentioned, two of the richest people on the planet have now gone into space as well, or sending people into space commercially. We talked about space sustainability this morning. So activities around space debris removal, life extension, those sorts of activities all require something that can be operated remotely from the Earth, and trying to eliminate humans from the loop and maintain the human activity for those things that only they can do. We talked about, Gemma talked about launch bearings earlier. There's a limit to what we can actually launch inside the dimensions of a rocket. So we need to be thinking about how we can assemble things in orbit. Those sorts of applications are a perfect match for our robotics capabilities. We've had 30 years of success with Canadarm and then Canadarm2. And here's a little summary of a few of the highlights from the past 30 years. Oh, I've done it again. So my final slide is just a summary of, what's next, where are we going? So in terms of MDA overall, we're going to continue our successful 50+ year story of investing in really customer-focused innovation and growing our space capabilities across our current areas of presence. And really the things that make us successful, or some of the things that make us successful, are leveraging the innovations that we have across the company. So an innovation that's developed in one part of the organisation can be shared with others, and that's one of the things that's benefiting us here in the UK. What I want to do is to repeat the pattern that we've got in Canada of collaborating and teaming with complementary teams within the ecosystem to support customer needs. And here in the UK, support those national ambitions for leveraging and commercialising and leading space-based and space-enabled systems. So I've got one final thing to show you, and this is really just an illustration talking about where we want to be in the future and the space for space agenda, and the types of technologies and capabilities that we're going to need to enable that to happen around things like assembling space-based solar power systems in orbit, assembling the Lunar Gateway. We need the most capable autonomous systems that are going to support the assembly of those types of architectures and infrastructures in space. So here's an illustration of a complex procedure that was done by Dexter just a few years ago.
Thank you very much, Anita. It's really interesting. We've got time for one or two questions, if there's anything anyone would like to ask. Anything from online? Oh, one at the back up there.
My name is Anita Bernie, University of Leeds. Thanks for a really great presentation. Online. Oh, sure, yeah, absolutely. Yeah, no worries. I'm used to the loud voice, so. Thanks very much for a great presentation. We've used the RadarSat data to do a lot of the work in Antarctica and glaciology that I specialise in particular, when you flipped the satellites to acquire images in the pole hole. That was a particularly ballsy move by the Canadian Space Agency. I'm really interested in your strategy to acquire multi-frequency SAR data. We have lots of instruments with different frequencies. You mentioned X-band and C-band. I was just wondering if you could expand a little more why you're taking the decision to go multi-frequency with your SAR rather than just sticking with one core capability.
Well, each of those bands is tuned. It's tuned to perform a. So I'm trying to think of the right way to put this, but each one's got its own role. So C-band is really great for kind of wide area surveillance and capture of data, whereas X-band is really good for the fine tuning. So having those two together provides insights that you wouldn't get from just using one. So it's like having, the wide aperture or looking down through a straw, and you need both of those. If you spot something that you think needs more attention, then you're going to want to go and look at it with something that can give you a bit more fidelity on that. But it goes beyond that. So within the geointelligence group and with RadarSat, what we do is not just fuse SAR data, but also other modalities as well. So we are ingesting Earth observation data, we're taking signals intelligence data, so that we get that really rich, multi-layered, multi-sensor insight that our customers are after. You know, they want to know, you know, more than what you can get with just SAR. So how can you provide them with that answer all in one package, so that they don't have to go to a range of different suppliers and try and fuse that data together themselves? They just need to get actually what they want is someone who's going to convert noughts and ones across all of that into just the answer they need, that's going to tell them where they need to go and look and what action they need to take. So it goes beyond just the SAR.
Great. Thank you very much, Anita.